All right. Okay. All right.
Sure.
Okay. So I'm getting started now. I'll give you some two, three good things. I'm going to start here, and let me start my presentation. And this is something. Let me tell you this. What it is all about, because in my presentation and everybody been I have seen, and this is not anybody's problem. This is a problem of software industry as such. Software industry, a lot of people from non-engineering background come here. There's no problem with that. And then what happen is the main engineering reasoning they don't follow, and because of that a lot of things go wrong, especially now, when you're setting up a AI transformation. That's what we're talking about. uh, so but in other engineering discipline like aerospace and all, they, because they come from that kind of a background, so they follow that engineering reasoning. So that's the reason I want to emphasize on that, and I'll explain what it is as and when required. You'll understand. So this is called engineering reasoning. We're going to follow a lot of stuff while we are provisioning things, and I'll explain what it is every point. I just Engineering reasoning is a whole big subject. Probably you need months and months to study, and you need to grow up with that reasoning. So I cannot just do it within 15 minutes. But I thought of, these are the 8 main points you need to understand, so that I'll make you understand. And then, okay, so now what else? Oh my god. Okay, now another very important aspect, which is also very important for the people, the companies that are implementing, this is called design thinking. Lots of people don't know what is design thinking, and lots of things go wrong because they start something wrong. So this presentation will talk about the design thinking processes, how to build an AI factory using this design thinking processes. Very, 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 interesting. You'll love it. You'll love it. But at the same time, while I'll be showing all the stuff and actually show how this design thinking process is implemented within AWS, and that's why it's become so easy to understand, and you're doing it, and you'll understand that. And if you understand that design thinking process, and if you implement in your own cloud implementation, it will be very effective, very nice. Okay. So this is something, like a large companies, Accenture, those kind of a companies, PwC, they always put this kind of a thinking in their process. So I'm just bringing that kind of concept here. Okay, probably something unique also here. All right, so this is I'll be talking about. All right, so these are the background. So now let's get started with our main presentation. And as I said, there are so many slides and all, altogether at 70, 80 slides. I don't want to go over all the slides and bore you, so I'll come back and forth whichever the relevant while doing it, and you'll understand. That's the idea. So the basic presentation here is, and I'll just go over for about 10 minutes of lecture, and then we'll directly go to the console. By that time, I think everybody should have logged in on the console. Okay, so I'm a AWS community builder also. I last time I was also invited to speak at the AWS reInvent. So I'm quite network with all the top AWS, gurus through my community builder. AWS, because of that, selected me as a community builder. So that is also, I'm part of this. I'm trying to spread the AWS knowledge. What the community builder does is, that he spreads AWS knowledge and builds the AWS community. Basically, he builds the AWS ecosystem, and he brings more knowledge into that, bring more people into that, and learn stuff that. So that is called AWS community builder. So I'm officially that. I have also another group which is an official AWS group of the Silicon Valley. Some people also joined from that group. So there is some official recognition here of what we are doing. And of course, this company Virtue, Solution Inc. is also a AWS partner. So we will be talking a lot of things from the partners point of view, and whoever the implementing partners they have, so they know they should have that kind of a knowledge, or they expect that kind of a knowledge from their implementation partner. So that is also one of the goal for this presentation. So having said that, let me start that. Building high performance AI organization, pretty cool. So what happens is, AI is a shiny object. Everybody talks about AI, AI, AI. So there are market hype and everything. And but how we can really build a high performance AI organization, and that is all about today's presentation, but with a lot of hands-on stuff. So I'll be talking more of I'll be showing it how it is done, basically. Okay. In a very simple way. Don't expect very complex stuff, because you have a free account, plus it takes days and weeks to really set up everything. But in a very simple way, you will understand the basic concept. So McKinsey says this is a $13 trillion economy for the next decade on AI, and some people are saying deep learning is like a $30 trillion economy. So as much as artificial intelligence is a game changer of a technology, unlocking its full potential will take time, scale, and expertise. So this is so the reality is that successful scaling requires more than just deploying AI technology, and this is what we'll be talking about. Because we are talking about deploying AI technology, SageMaker is so robust, so powerful, you can do many things. I'm going to show you that. But is it really worth it? Is it really worth spending the money? How you can really spend the money? Where what kind of a benefit you are going to get, what kind of a technology advancement you are really trying to achieve. So those question comes when those kind of a question comes, again design thinking comes into play. I'll just explain what it is. So now you can see this, the digital network and AI transforming the business and society. So traditional business like that, now every firm is digitizing. They call it, the new term came to digital. So what the digital is delivering customers value, and how you are going to earlier they didn't customer you deliver the customer value. Of course, yes. 20-30 years ago, there wasn't a company that was not delivering the customer value. Yes, they were. That's why these companies become so big. Walmart and IBM and all those companies. But that was different. That was not the digital era. So, so basically, two types of business model we see it. There's a value creation in the traditional sense. Then you capture the value and you create the business model, and that was the traditional way. But the real nowadays, when you are talking about digital, business, so you don't, and then you have the operating model, and then that you have the business model, and then you have an operating model, and that you deliver the value customer through all this brick and mortar old traditional stuff. So how this value of a company changing, software, network, and AI, that is what we'll be talking about now. What happened is, now we are talking about building a value, because now building a value is so beautiful. Because if you have read economics 101, there's something called marginal cost equal to marginal revenue. But because as you increase your revenue, your cost also increases. Here, as you increase your revenue, your marginal cost becomes almost insignificant, because you are growing with your digital asset. That's what Amazon grew so fast, because although they have a brick and mortar operation like a storage and other stuff, warehouse and everything, but their main everything is built on technology, and it really they can really expand it fast. Think of Uber, the world largest taxi company. They don't have even a one taxi. Okay, but they just expand their network so fast that I think 70-80 countries, I don't know how many countries they are operating now. And so they just connected. So that's called digital asset, and those digital assets spread. But the marginal cost is very 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 insignificant, because they are really expanding their network, digital network, not their physical network. Few satellite office there will be always there here and there, but not like a setting up a big factory, like a big, in everywhere. That kind of a thing is like a thing of past. So now we are talking about data processing pipeline. We'll be talking about your data is coming from all kinds of sources, and then you discover data, you extract data, you transform the data. That our first lab will be data transformation. Then you just do the analytical modeling, and then you do some data governance, because you have to really control data. What kind of data? There will be a lot of garbage data, this, that, so many. So there has to be a data governance, and then you build your algorithm. So first you have to build your data processing pipeline, and then you have to build your algorithm. This like a two-step process. You just cannot have algorithm without really having a really solid data structure. That's the reason data processing and data, your exactly data strategy is very important, and that's what we'll be talking about today more. Okay, now when you use the full power of digital network, I'm not making you bored on this, because there's so much into it. I just, a lot of theoretical lecture. I really don't want to. I had theoretical lecture, throughout my life. I mean, it's something practical you can really understand. So what you do is transition from siloed, disconnected IT to true software data platform. So what will happen is, so you create a digital agent basically. So what this digital agent that it can communicate at a zero marginal cost, as I mentioned already. The marginal cost is insignificant, okay, and virtually infinite number of other digital agents. So you create a digital agent, and each digital agent is like a very very self-sufficient, you know, infrastructure, cloud, AI, ML, all the data and everything, and then you connect, and then you make up your whole world, like a digital this thing. The same digital agent can be easily connected to the complementary activities, and we're going to talk more about that. Can be embedded processing instructions. So this is, so you create a digital agent, you create a digital agent, you create a digital agent, and then you created your entire company's digital brain, and it's all integrated such a way that it's like a one strategy, but it's really working, very very. It's like your own brain. You have only one brain, but you have different parts of the body. Your hands has some other function, your nose function is different, your heart function is different, but everything is controlled by your brain. Similar, just think of it, your corporation will be like that. You have different department, different function, different locations, but it will all be controlled by all those digital agent, and each just like a neurons. Every neurons has a different functions and stuff like that. So those digital agents will be like a working like a neurons. It will control certain function of the organization, and then you make the interest stuff. So this is what we have been talking about. So becoming an AI powered data company, and I'll tell you this why everybody wants to be a data company. I'll give you an example. I think about 2 3 years ago, Google declared that every company has to be a data company, or the company is going to die within 5 years, and which is true. So then everybody woke up. Oh my God, we need to be a data company now. He said, yes, you have to be a data company. Why? Because your data is only that matters. I'll give you an example. Very, 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 very easy example. Suppose you are a manufacturer, and you are manufacturing plant. Suppose you make cars. Okay. So you have manufacturing plants in say 60, 70 different countries, or different time zone, different thing. But all those manufacturer, they are manufacturing cars for the local market as well as some other market also. So every market has its own kind of a niche, kind of a requirement, and all those market, all the data is coming from all the market, from right from the customer data, production data, financial data, and other data, all those local data. You need to really consider and then find out, because all you're doing is data. You're just playing with data, different data. Okay, if you're going to a country like India, their roads are different. So the same Toyota car which is operating here in United States may not be, although the model will be same, but there could be a different requirement because of the roads are different. Probably they have the better shock absorber and some different kind of a tire. So the local need needs to be customized. So all those local needs to be customized. First, you have to really collect all data, and right from the collection of data from the ground level, and it's going to the marketing department, the sales department, the finance department, the research and department, and the engineering department. Everywhere, wherever it is going, actually data is going. Okay, and then based on the data, based on those informations, they are just modifying everything. Probably they are modifying the design. In order, when you modify the design, you'll have to also modify the manufacturing facilities, because there could be a different parts or different kind of thing will be required. But as you see it, look at it, if you close your eyes, what is going on, you'll see that is flowing information from one part of the company to another part of the company, one department of the company to another department of the company. And every company is taking that information, and they are tailoring that information and customizing that information to whatever the requirement they really need. Had marketing has different requirement, R&D has a different requirement, sales has a different requirement, engineering, manufacturing. But all those information are flowing. But how those information are flowing? Those information are flowing in terms of data, because those are all data. And that's why it is called data company. So when you're talking about data company, means all those information now, earlier 10 years, 15, 20 years ago, there is a way to collect all the data and information were there, but nobody knew how to what to do with that data. Locally they could do something, but collectively all those intelligence was not there. That's the reason artificial intelligence, machine learning, and all those things really started popping up. Now the company thinks, hey, I need to be a data company, and they're thinking, okay, let's put all the shiny object and become a data company. And that's the fatal mistake they make. And that is what that is what the whole thing so a lot of companies even died because of that. They went bankrupt because they bought so much money, but they didn't understand really the very basic of the how to build a data company. So this is what, say, one strategy: architectural clarity, agile project, product focus, capability foundation, clear multidisciplinary governance. Having said this, you create a value, and then you create a value dynamics. And as you create a value dynamics, you create a AI powered network. Now you tell the reason why AI became so successful, or it's becoming so successful in last, I would say, like a 10 years, a little less than 10 years, less than last decade, because of one thing, because of cloud. Because in order to run AI machine learning, you need humongous amount of computing power, humongous amount of storage. And cloud is cloud computing provides that unlimited storage, unlimited computing. You just hook up with one availability zone with another, one data center with another. You have the digital network. You can really have any kind of a computing power and storage you need. And machine learning, AI, and all those big data stuff really require that amount of computing power. And that's what the it happens. So AI powered network consists of an array of sub networks, social networks, supply chain network, mobile apps network, and all those things. So, and this is very important. According to MIT, only 13% of the organization excels at delivering on their data strategy. This is absolutely, absolutely important. And this is really happening. So people who are really into this kind of a business, there's a huge, huge, huge opportunity here, because only 13% of the organization excel at delivering their data strategy. So that remain 87% of the organization who need to become a data company, or who are in the process of data becoming a data company. They really need you if you have the right, guidance, right tools, and the right engineering knowledge to really become a, very, very, a good data strategy, to implement a good data strategy. And that we'll be talking about. I'll show you some stuff. So the main success factor is data duplication reduce and all those things, the data lake, concept of data lake, and I'll be showing that. So how do you build high performance AI organization? Effective enterprise data strategy, well architected machine learning life cycle. We'll be talking about that. Production grade operation and deployment. We'll be taking something on the production grade. You have to have a continuous integration, continuous training, continuous development, all the DevOps stuff. Now the DevOps converted into ML ops. We'll be doing some. We'll create a ML ops pipeline. We call SageMaker pipeline. You'll be doing it. It's very interesting. You'll like it. The ML ops support the different languages and ML framework. I'll also show you how it can be done. Integration with other third-party system, authentication, authorization, and artifacts management. So the core requirement of ML enterprise architecture, ML ops, governance, all those on and on. So I'll be whatever I'll be showing it, I'll just highlight it, and rest, you can read anytime. Okay, so this is operational excellence. You have the well architecture machine learning cycle, and then you have the model deployment, you have the data processing, you have the deployment, you monitor, you have your business goal, and this is like a cycle, and then you have the operational excellence. And these are the five pillars of AWS. People who are AWS cloud, have background and who are certified, they know the five pillars of AWS. It's called operational excellence, security, reliability, cost optimization, and performance efficiency. So these five pillars of AWS are there, already there. And on top of those pillars, you build your own, AWS machine learning lens. It's called. It says AWS white paper machine learning lens. Please go and download it. I downloaded it from AWS white paper. This is not my diagram, but this is what it is all about. Okay. So I'm not going to talk about. So these are the different workflow services. Amazon SageMaker will be doing a lot of stuff. Amazon Deep Learning AMI, deep learning container. So see, now every lot of things are happening in deep learning, and that's the reason I have a solid deep learning, some kind of solid foundation hands-on workshop today. So you will like it. And then AWS batch, parallel cluster, all those things. Then there's a framework that you need, a machine learning framework. Most popular is TensorFlow, PyTorch, then MXNet, Keras. Will be using Keras and TensorFlow today. PyTorch is also actually TensorFlow is more of a Google stuff, and PyTorch is a Facebook thing. So, but PyTorch is becoming a popular, but TensorFlow is more popular, and Keras is that framework that supports the TensorFlow. We'll be using a lot of Keras today. And then you have the these are the different CPU requirement and GPU, and then you have the elastic inference. I'll be talking about that. And then Amazon S3, all the storage. I'll be using it. I'll show you how to do it. Amazon EBS volume, will show it. And then, this is when you have a large, storage FSS and Amazon EFS and all those things. I might mention briefly on that, but it's more about storage basically. Okay, so this is the AWS ML stack. You have the application service. So these are like already there, so you don't have to do it. It's pre-built model there. And then you have the speech poly, language lakes, Amazon machine learning platform. It has like a 7 different algorithm. You can use it. And then Spark and EMR. If you know what is Hadoop, and if you are good at Hadoop, or if you have used Hadoop and big data, so this is a Spark EMR is a part of that Hadoop thing. And then Mechanical Turk is like the Amazon has created some platform, some kind of the crowdsourcing platform where hundreds of thousands of people can go and label your data and everything. So but a very, very fraction of cost, something like a 1 cent, 2 cents per level, or something. I'll briefly talk about that, what it is. Okay, and then you have the deep learning AMI, you have the TensorFlow, we'll be using TensorFlow, and cognitive toolkit, Cafe, PyTorch, Keras, will be using Keras. I'll show you. GPU, I'm sorry, I'll show you, but you cannot use GPU because for free account you cannot. But I'll show you. I can show you on my this thing what it is. And then you have CPU, this IoT, green grass, and mobile and stuff like that. So with the effective data strategy, what you have to do it is first. It's very important is data processing. So what you have to do is data processing is like a. Let's think of it, when the data is coming from all directions. Okay, your transaction data, financial data, customer data, this thing. But with that data there will be a lot of garbage data are coming. So when you are really trying to use data properly, and thus the proper data strategy has to have a two main goal. First you have to clean your data. You don't want garbage data, because if you have more garbage data, all your machine learning, this, that will be based on your data. And because they are all garbage data, and if you have not cleaned it, then all your prediction will be false. So you'll never be able to achieve even 10% of your ML and implementation goal. So we have to clean that garbage data. And even after cleaning the garbage data, you have to govern that data. How you are going to govern it? How you are going to do it? So it's a data processing, so, and data collection, you have to label it. So data preparation, data wrangling during interview. So what we are going to do it, let's go to the lab right away.